You're welcome, Johannes. You're welcome, Ripi. Please go on with your presentation. Thank you very much.
Hello, everyone. Thank you very much for inviting Dr. Vrana and me to share with you our thoughts on bringing Industry 4.0 into the non-destructive evaluation in the new discipline we call NDE 4.0. My talk will be all in English, and hopefully the subtitles would cover up for some communication gap because I do not know Spanish yet. Okay, we're going to talk about the why, the what, and the how of the fourth industrial revolution. I think by now everybody knows how it has evolved over the years, starting with the steam power in 1784, then electric powered in 1870, then computers after 1969, and today we have a confluence of digital and physical technologies. But what does this mean to inspection? Well, the inspection over the last 100, 200 years has changed significantly, going from what we call visual inspections as NDI 1.0, and we really use the term NDI that time because it was pure inspection. Then we moved on to analog techniques, dye penetrant, mag particle, eddy current, all of those, which were the early instruments that allowed us to look beyond the surface, to look behind the hidden material. Then the third revolution with the computers brought about different ways to visualize, different ways to store data, to be able to analyze data. And now we have more technology coming into inspection, testing, evaluation, diagnostics, prognostics, and all those disciplines required to maintain safety and quality. And these technologies include artificial intelligence, robotics, augmented reality, cloud computing, 3D printing, and many more that Dr. Vrana will talk about in 10 minutes. What does this mean to us? So today's talk, I will spend about 5 minutes sharing with you why NDE 4.0 is important. Then Johannes will give you an overview of what does it contain. And then I will come back to share with you how to go about innovation and bringing the digital technologies into the NDI business. Let's start with why. So the why of NDE 4.0 is obviously combination of why we do NDE and why we want to do Industry 4.0. Well, the inspections are done to assure safety, to assure quality. In operation, we want our asset, whether it's an airplane, a jet engine, a bridge, a train, we want all of them to operate safely. In a factory, we want good quality. But all of these technologies, they are here to actually improve the quality of our life. They are here to give us a better healthcare, a better way to move around, renewable energies, cities, and infrastructure that is smart, that allows everyone to have a beautiful, cherishable life. And this is what Japanese defined as Society 5.0, which is around both social values as well as economic structure. When you translate that into NDI, it means safety and economics. It means safety of the infrastructure, safety of the inspectors, and the economic value both to the owner of the asset, the operator of the asset, as well as bringing high skill jobs for the inspectors. That is why we want to bring in NDE 4.0. Now, I think we all understand the concept of POD, probability of detection. As the anomaly size goes up, the probability of detection reaches 1 asymptotically. Now, equipment has an intrinsic capability, but in reality, the human factors bring the system reliability a little bit different than the machine or device capability. Humans, with the equipment and application, end up making false calls and end up missing anomalies of a certain size. And that's why we define 90-95 as a crack size, as a POD, to establish a system reliability. Our inspection programs are all defined around the 90-95 crack size, whereas we have the inspection capability to detect much smaller anomaly sizes, whether it is crack or corrosion or wall thickness loss or whatever. So there really is an opportunity to bridge this gap by reducing human factors, by bringing in robots, by bringing in more automation, by bringing in machine vision. And that's what I want NDE 4.0 to do, to push the reliability as close to capability as we can. So all of these factors, I want to reduce those so that I can eliminate the false calls, I can eliminate the misses, and get as close to the capability. Now, there's another opportunity. When you bring automation and artificial intelligence, you might actually be able to push the capability even further to almost a vertical line, to almost going to what we physically is possible. And that's the whole reason for NDE 4.0. Typically, when we do a project, you can choose 2 out of 3 things. You can either make it cheaper and faster, or you can make it faster and better, or you can make it better and cheaper. It is very difficult or nearly impossible to get all 3 together. But when you are in a technological revolution, for a period of time, when you are bringing in advanced methods, you could accomplish all 3. And that is what causes urgency to bringing in NDE 4.0. That's what we are trying to go after. Now, let's look at what does it entail. It essentially entails a coupling of the physical system, the physical inspection system, and the digital technologies, the computers that analyze the data, the computers that make prognostics. Now, we want to use the same NDE 3 physical methods, but bring in digital technologies which are continuously developing. This closed loop where a sensor picks the data, computer interprets that into a meaningful action and takes the action back into the physical world is what is NDE 4.0. And this closure of the loop is what differentiates NDE 4 from NDE 3. I want to emphasize that we come across many of our very smart colleagues who make statements like, we have been using digital radiography for 20 years. Good, that is still NDE 3.0, that is not 4. Until you can close the loop back to the physical world, you are not yet at NDE 4.0. With that, I would pass on the controls to Dr. Vrana to continue with those digital technologies that are here to differentiate NDE 4 for us.
Ripi, muchas gracias por su introducción al porqué de ASNT 4.0. Y hola y bienvenidos al mundo de los ensayos no destructivos 4.0. Mi nombre es Johannes Vrana y muchas gracias por la invitación. Pero mi español es terrible, así que continuaré en inglés. Ripi already talked about the physical digital physical loop, which Industry 4.0 and NDE in 4.0 actually introduces to us. But, well, doesn't work. But I will go one step further and go to 3 terms, which both the German and the Spanish language do not differentiate that exactly as the English language does. Digitization and digitalization, to my knowledge, they are the same word in the Spanish language, and they are the same word also in the German language. But there is quite a difference between those 2 terms, and an important difference. Digitization is just the transformation of analog information into something digital. So I take a sheet of paper, I put it in a scanner, I produce a PDF out of it. That is digitization. If I go to digitalization, now we are speaking about making our processes digital. So you can see the digitalization is clearly one step ahead of digitization. Digitization is the 3rd revolution. Digitalization, now we are on the way to the 4th revolution. And digital transformation, which is exactly the physical, digital, physical loop, that is the 4th revolution. Now, the idea behind digital transformation, digitization and digitalization, I can kind of do within my own company. But digital transformation is such a big project, it will take multiple players to actually accomplish this goal. Now, when we first started talking about NDE 4.0, people were clearly talking about those emerging technologies, extended reality, artificial intelligence, and so on. Now, they all apply a kind of tiny physical, digital physical loop within our NDE world, which is a good use case. And I call this use case Industry 4.0 for NDE, or emerging technologies for NDE. And we can also put into that group something like inspection support. In particular, during times like we have them now, where we cannot travel to a location where our customer needs us to travel to, we use somebody who is already at the location. We need the inspection to be happening, and we create a remote support so that we have a specialist then helping the person who is actually on site. We can use that information also to improve our NDE equipment. We can establish processes for NDE, digital workflows, digital supply chain processes. We can establish component traceability, life cycle records, or also performance statistics. If we think about, for example, certification, personal certification. Now, there is another big use case. And what I did a couple of months ago, I asked in social media what people heard on negative things about NDE. And this was one of them. NDT does not have any value at all. It only sorts out parts that in reality are good. I don't want it, I would never ever do it, but my customer insists on it. I would prefer spending the money into further improvement of my production. Now, I don't think that this customer really sees the whole story, number one, And I don't agree with this opinion of this customer. But this customer actually shows us a way out, the way he wants it to have. He wants to improve his production. And we, as an NDE community, can exactly help him to accomplish this. We have all kinds of data from the interior structure of the product. So why do we not use all of the data, give it to him in a way that he can process it, and he can use it to improve his production? So by using NDT, he actually gets exactly what he wants. But what do we do instead? We put all our results on paper or on PDFs, and we put it in an archive. So what we need to do, we need to enable NDE for Industry 4.0. NDE acting as a data source for Industry 4.0. Now, how do we get there? If we look in industrial production, and this is now coming from Industry 3.0, from the third revolution, you always see this automation stack, where we have on top the Enterprise Resource Planning System, ERP, where we plan an industrial production. Then it is going downstream until we reach our production floor. We produce something, and then the information is condensed back and ideally going into the ERP system so that somebody can do some statistics on number one, all the numbers, all the financial data in the ERP system, and number two, all the data from the production. Now, this system has three challenges. Number one, we need a lot of interfaces. Between one layer and the next, we need interfaces. And in particular, between the PLC and the SCADA level, we have thousands and thousands of interfaces we need to establish. All those PLCs are by some OEMs, and each of them has their own proprietary interface. So to connect PLC and SCADA, this is a few thousand interfaces, and therefore only the really interesting PLCs are integrated. There is an even bigger gap between MES and SCADA, because in most industrial productions, what happens is somebody prints what should be produced, then this is given to somebody, and this sheet travels with the component from one equipment to the next during the production. Now, if we have this paper downstream, how do we get our information from our shop floor up into the MES and ERP system? Yes, we scan documents and put it as a PDF in the MES and ERP system. But this is not data MES or ERP can use. Moreover, this is only production. But if we think about it, we start thinking about production way before we actually do it. We first do the engineering of a new product. And for that, we use, for example, computer-aided design. There is some weak link between the CAD system and the ERP system, but this is just a weak link. Same for all the data coming from our supply chain. All of the data coming from the supply chain would be valuable information for to have a better industrial production. Same with product lifecycle management. Same with maintenance, structural health monitoring, digital twin and thread, or a cloud. So the idea is, let's get rid of all of those difficult to handle interfaces, and instead of that, let's use one industrial Internet of Things, connecting everything with everything. Now, where do we have NDE in this whole picture? Structural health monitoring, this is NDE. But we have a lot of NDE in production. We have a lot of NDE in maintenance. We have a lot of NDE at the suppliers. But again, we do the NDE, we write a report, we print it, we sign it, and we put it in an archive. So instead of putting it into an archive, let's use digitalization for our NDE, or digital transformation. And let's bring NDE into the industrial Internet of Things. Now, how do we get there? What we need open, standardized interfaces, number one, so that we do not have to have millions of interfaces. No, just one interface for all of them. But what it also means, we need a structure of our data. We have to make our data machine readable. We have to convert it actually from data to information. So what does that mean? Once I show the next slide, I would think at least half of us will immediately know what that number I will be showing means. But if I enter this number into a computer, the computer has no clue what this number means. Yeah, the computer doesn't know, is this number 42? Is this the length of a truck? Or is this the gain of the UT instrument? Which probe was used to have that gain? Was it before or after calibration? Which component? Now, if we tell the computer all the surrounding details to that number, the computer will also understand that this is actually the answer to the ultimate question of life, the universe, and everything, at least according to Douglas Adams and his book, Hitchhiker's Guide to the Galaxy. So what we need is semantic interoperability. And we can use the semantic interoperability not just for IoT and for data formats or interfaces. We can also use it for cloud, for digital twins, for databases, and for AI. Because then an AI understands how to do the interpretation of the data. But the really interesting part is actually the digital twin. Now, an example for a digital twin, I can do a digital twin of myself. A digital twin is nothing else than a digital replica, a virtual representation. And to create a virtual representation about myself, first off, you need a lot of data. Then on top of the data, you need some mathematical algorithms to predict my future behavior. And finally, you need something to visualize the results. Now, those three here, they exactly know how to do it, and they make a lot of money with exactly this concept. The same actually goes for health insurance, tax offices, and the governments. They all collect a lot of data because data has a value. Now, if you think into the technical world, then yeah, we can do a digital twin of an inspection system. We can also do a digital twin of a complete production line. And within the digital twin of the production line, we have then several of them. One for a mechanical, one for some machining, one for the inspection, one for some measurements, and so on. So we can have hundreds of digital twins within another digital twin. Also, as a sublayer of our inspection system, we can have some inspection equipment, detectors, probes, sensors. We can actually also do a digital twin of a software. Now, if you think about all of this is actually related to equipment which is used to either produce or to inspect something. And if we think about in a production environment or an inspection environment, we also have a lot of humans doing those. So also the human can be described actually as a digital twin in his profession he is doing in the production. Now, this is all digital twins related to certain, to a production line or to equipment. But we can also do a digital twin of a product, starting with a digital twin of some raw material, going to digital twins of components, and finally coming to a digital twin of a product. Now, for sure, either it is a product like this, which we can use on our everyday for transporting, or it can also be a product which actually is finally equipment to produce something else. So, a digital twin, both for equipment and product related. We have three key components to it. One is information. We need a lot of information. We need some mathematics, some algorithms, some simulation to actually process all of that simulation. And finally, we need some visualization. Now, the data we need for the digital twin doesn't have to be stored in the digital twin. The digital twin only has to know how to access all of that data. And it is important that it is data actually with semantic interoperability so that the digital twin can automatically use that data for the next step. Now, for the next step, we can use classical computers. We can use artificial intelligence. We can use quantum computers. And all actually for tools like trending, predictive maintenance, probabilistic lifing, behavioral analytics, risk modeling, reliability engineering, and so on and so on. Those are all the things which are in the core of the digital twin. So you can already see we are using all those emerging technologies we have, and we put them all here into the digital twin. And finally, for the results, yes, now we have to visualize them. Either we do that using a dashboard, or we use them something like an augmented reality. So coming back to Ripi's physical-digital physical loop. And I think now you can see that this physical-digital physical loop is a lot bigger than what people discussed in the beginning. We take NDE data, we put it into the industrial Internet of Things, where it is combined with all other data, then we put it into a digital twin, we do some processing, we visualize it, and finally we can actually, due to the results of NDE and all other data sources, we get better products, we get better designs, we get better maintenance. And we started kind of with NDE being an unnecessary cost factor, at least to some customers. But I think NDE 4.0 is the tool to actually make NDE the data treasure, or one of the most important data treasures for Industry 4.0. Ripi, it's your time.
Thank you, Dr. Vrana. Wonderful, quick overview of what digital technologies and the physical NDE together can do for us and how we can leverage that loop. Now let me wrap up this presentation for today evening in the next 10 minutes and talk about how should we pursue it? How do we go after adopting this? So one of the important items that Johannes talked about is system connectivity. We need protocols for data exchange. We need protocols that will allow us to send information from one machine to another machine and back into the equipment. HL7, OPC UA, those are the protocols which are being developed now. DICONDI is another one that might win the race and become a popular one in the near future. One of the things which, with most of my customers adopting Industry 4.0, I always recommend, think what a smartphone can do for you. The smartphone has so much processing power, ability to see using a camera, ability to communicate, store data, to do simulation. It's so much easier for NDE community to focus on the sensors like this one over here and use everything else within a smartphone. Think of it like the wheel in the fourth industrial revolution. Talent and workforce development is the next big thing for the fourth industrial revolution, because this one is heavily dominated with information technology, intelligent systems, programming. So we have to think about upskilling all of our workforce, including level 1, level 2, level 3 inspectors who would then be involved in working with NDE 4.0. To be able to develop these systems, we also need a process that can allow us to go from understanding why we should bring in Industry 4.0, where we should bring in the digital technology, and from there generate ideas, figure out ideas that make sense to the customer, which have a value proposition, and then qualify those concepts which are financially viable to make. We know every idea cannot turn into a project. If you have hundreds of ideas, maybe only 10, 15, or 20 will make sense to the user. And out of those, only 4 or 5 may make business sense, which means you can execute them profitably. And then only 2 or 3 out of those may actually become a successful project. We understand this funnel very well. And through this funnel, you have to use various tools. There is a suite of tools that exist in the marketplace. We use many of them. So almost more than 50 processes and 100 different tools can be deployed, starting from capturing the customer need to creating a technology or a project that adds value. A lot of these tools we have published in form of books, and they are available. You can buy them on Amazon. On Kindle, they are priced really low. Each one of them can take you from your purpose as to why you want to adopt a new technology to actually adopting the new technology and developing a mindset so that the workforce can go through the digital transformation. Another piece of information that can be used is ISO standard. We heard about ISO earlier today in terms of 9712, but there's also an ISO 56000, which started about 4 or 5 years ago, which tells you how to adopt innovation. And this is specifically being written to address the changes that the world is seeing now with the digital revolution, with the fourth revolution. And top of all of this technology and process and tools, the adoption of Industry 4.0 also needs a little bit different leadership style, a style where hierarchy does not really work, an environment where competition is highly unpredictable, in addition to rapidly changing technology. So there is a term that has come up, which is Leadership 4.0. I will not go into the details of that, but this is also an area which needs a little bit modification to adopt NDE 4.0. So most importantly, you should start with the right set of questions. Think about whether you are adopting artificial intelligence or digital twin. Ask yourself what system, which is method, product, process, you need to adopt. What is becoming obsolete and what is now coming up? We just talked about inspection skill set. We should not be worried about jobs. A lot of people say, will Industry 4.0 take away the jobs? No, but it will take away the skills that you currently have. There will be new jobs which need new set of skills. It will make your competency obsolete, but there will be a lot more jobs in the future. Getting into the digital world also creates opportunity for new business models. Just like Dr. Vrana mentioned how NDT can go from a non-value added activity to a data trayer, it means there are new ways by which you can convert data into money. But remember, all this must produce a good customer experience. Eventually, that is what matters in business. That is what matters at workplace. And finally, I would like to mention that as we adopt new technologies, they come with new ethical challenges. You will struggle with doing things for which there is no regulation, for which there is no precedence, and for which there may be a business motivation to adopt. So that area needs to be handled with attention, needs to be handled delicately. Also, the changing human role will bring about new problems. Inspectors will go from doing the job to controlling the robots that will do the inspection. This could bring out new sources of mistakes, new errors, different type of human factors. There could also be an overtrust in automation. Just because you have a robot and it's been proven to be more effective than some of our human actions, that does not mean that you can over-rely on that. You must still manage it correctly. And of course, there are unforeseen technical challenges with integration of all this that we have to be careful about. So while I say that the motivation is to bring the reliability of inspection as close to the capability, there are still some challenges that we may not fully know, and we have to take these changes with caution. And it is a journey. This transformation will not happen overnight. It could take a few years. There are multiple steps, and we have to learn along the way. The end is not very clear at the moment, but some of us have to work to create what makes sense. What makes sense is a technology, what makes sense from business perspective, and what can make sure that eventually safety is our purpose. But we have to do this together. And working together is not just better, but that is the only way, because it's all about networking. It's all about connecting people and machines. So that is how we will go pursue the adoption of digital technologies into the NDE world. And it's a journey. And together means we have to work like a community. We have to think of the NDT 4.0 as an ecosystem where all of us, the people who make the assets, people who own the asset, people who inspect it, people who develop inspection equipment, they're all focused on the asset and asset consumer. Johannes, your turn.
Yes. So, and this is exactly why we actually built up an international group, which actually tries on a global scale to develop currently a roadmap for NDE 4.0 that together we can shape that future for the complete industry. We are also working on a handbook of NDE 4.0, which was started by Norbert Meindorf, with all kind of national society groups on NDE 4.0, like the German Society or the American Society. We also have an international, an ICNDT specialist group on NDE 4.0. We have also started multiple knowledge bases. For example, the NDE 4.0 YouTube channel or the upcoming conference on NDE 4.0, which will be actually in April 2021 virtually, and then in April 2022 in Germany, hopefully face-to-face. And let's see when we will have the next WCNDT. I hope that 2024 I will be able to visit all of you in Argentina and that we can discuss NDE 4.0 in Argentina. Now, we also started, and actually it was Ripi starting this group of ambassadors, where we have one person from about every country, and it's growing every day. And what I already said, we are currently in the process of developing a roadmap where we try to identify, first of all, the major stakeholders, the technologies and processes, and the skills for NDE practitioners. But we, as an international group, will really focus on this roadmap on the global scale, and then see, okay, what can we do on a global scale, and what needs to be done actually then on all the national society levels, where they bring really in, they have to do most of the work. What we can only do, we can think about the big picture currently.
So the challenge with the Industry 4.0 is that it is here. We cannot deny the fact that digitalization and digital transformation is happening. And we can either choose to be a leader, or we can choose to follow a leader, or we can say, let's wait and watch. We can be an observer. Most of my clients ask a question, who should we hire? And I tell them, if you want to be a leader, you should hire a chief innovation officer. If you want to be a follower, you want to hire a chief risk officer who will tell you what to follow and what not to follow. And if you just want to wait and watch, then you hire a chief prayer officer, because this revolution is here to change everything that we have been doing up until now. With that, I would close today's presentation. Thank you. Dankeschön. Gracias.
Muchas gracias.
Thank you very much, Johannes and Ripi. Great presentations and very clear. We want to be in this group, certainly, and we will keep in touch with you to work and develop this model in our companies based on your experiences. Thank you very much and good night.